Hello everyone. In this video we're going to be solving an exponential and maybe logarithmic equation, both. So we have x to the power ln x equals 10 and we're going to be solving for x values. I'll be presenting two methods. Let's start with the first one. I'm also going to show you a graph at the end, which is kind of cool. So let's start. For my first method, I'm going to log both sides. I could also ln both sides because we have a ln x in the exponent. But since we have a 10 on the right-hand side, I wanted to start off with logging both sides. Log, by the way, is base 10. I don't write it, but it's base 10. Okay, so log 10 would be log 10 with base 10, which is equal to 1. Awesome. Using properties of logarithms, we can go ahead and move this to the front. And that's going to give us an interesting result. ln x times log x equals 1. That's kind of interesting. I could probably isolate one of them and write ln x as 1 over log x, or write log x as 1 over ln x. But that doesn't really help, does it? So this is kind of like an interesting relationship between these two things, but the problem is these two logs have different bases. So they're different. So what should we do? We can use change of base formula, right? Obviously, and it can be used in different ways. So whatever base you choose, you can go with that. In this case, I'm going to use ln, which is the natural logarithm. How does the change of base formula work? Let's talk about it briefly, and then I will use it. I'll apply it to our situation. So if you have something like, say, log a with base b, then, and let's say we want to convert it to base x, we can kind of write it like log a over log b with the same base. Make sense? So a goes here and b goes here. And notice that these two bases are the same. So this is called change of base formula. So let's go ahead and see how it can be applied to our situation. And it's kind of nice because since I want to use ln, log x basically is log x with base 10. So now this turns into ln x over ln 10. Notice that x goes here and 10 goes here. Make sense? Okay. So now we can do the following. Replace log x with that ln x multiply by ln x over ln 10. Now what's really cool about it is that ln 10 is a constant. It's not a variable. That's good because 10 is a constant, right? So ln of 10 is constant. And we have the same base now, ln x times ln x, which is really, really cool. So let's go ahead and cross multiply. ln x times ln x is going to be ln x squared. Cross multiplying gives us ln 10 times 1. Great. So what is that supposed to mean? Well, if a squared equals something, you can square root both sides, but you have to use absolute value because the square root of a squared is absolute value of a, which means if a is positive, this is going to turn into positive a. If a is negative, it's going to turn into negative a. So we have to consider both cases while square rooting. So this means ln x is either square root of ln 10, because this can be expressed as square root of ln 10 squared. By the way, ln 10 is a positive quantity. Or ln x equals the opposite of that. Think about it this way. Like if you had an equation like a squared equals 4, you would get two solutions, right? A equals 2 or a equals negative 2. So that's the same idea. Okay, so now we got ln x, but we do need x. So what should we do? We should do e to the power both sides, because I think we should all know that e to the power ln x is equal to x. This is a very, very important relationship between x and ln x. So we can do e to the power ln x equals e to the power square root of ln 10. And e to the power ln x can be written as x. So x equals e to the power square root of ln 10 is one of the solutions. And similarly, the other solution is going to be x equals e to the power negative square root of ln 10. So those are going to be the two solutions, and there are only two solutions to this equation. By the way, x mustn't be negative, x must be positive, and it is, because e to the power negative something. E to the power anything is positive because e is positive, right? We have a positive base, so it's all good. All right, so those are the two solutions. And let's go ahead and take a look at the second method. And gonna let me know which method you like better and which method is easier to understand. So let's rewrite the original problem one more time. We have x to the power ln x equals 10. So for my second method, I want to use something slightly different. I mean, obviously, they're not going to be completely different. A lot of times people, or I shouldn't say people, but some people think that these two methods are the same. They are different because we kind of use a slightly different approach. Obviously, they turn out to be the same thing, sort of. They're related because we're solving the same problem, but sometimes they're very close. Anyways, I talked too much, so let's get on with the solution. So I want to use substitution. How about replacing ln x with another variable? Obviously, replacing x with another variable wouldn't make sense. It would be the same thing. So let's call this u. How about that? So this is about u. We have x to the power u equals 10. That doesn't help. Let's go ahead and find x in terms of u. If ln x can be written as u, and since the base is e here, you can kind of sneak it in, x can be written as e to the power u. Or if you want, you can do the e to the power thing again, and that way you're going to find that x can be written as e to the power u. So that's what we're going to substitute here as well. So this gives us the following, which is really cool because this kind of takes you out of the log territory and puts you into the exponentials territory. So x is going to be replaced with e to the u, and that is going to be raised to the power u equals 10. So e to the power u is going to be e to the power u times u, which is e to the power u squared. Awesome. Now, what do you do if you have e to the power a variable? What's the answer? You ln both sides. You want to bring down the power. So let's go ahead and ln both sides. And that gives us something that should look familiar to you. ln 10. Yay, we got this before. So now we're going to do the following. We're going to go ahead and move this exponent to the front. U squared times ln e, but ln e is equal to 1. So we can just write it as u squared equals ln 10. And from here we get two solutions like before. Remember, there are two numbers whose square equals ln 10. Right? And ln 10 is positive. Why do I keep saying that? Because if you got something like u squared equals negative ln 10, this would not have any real solutions because u squared cannot be negative. Okay, so from here we get either u equals square root of ln 10 or u equals negative square root of ln 10. But what is u? Or what are you? No, it's not what are you, it's what is u. U is ln x. So if ln x is equal to this, square root of ln 10. From here we get x equals, well, you know what, I'll write the solutions down here. There's not enough space. And here ln x equals negative square root of ln 10. So this gives us x equals e to the power square root of ln 10. And the second one gives us x equals e to the power negative square root of ln 10. And those are the same solutions that we got before. Let's go ahead and take a look at the graph real quick and we'll finish up. So here's the graph of y equals ln x to the power ln x. Remember, we looked at this graph before. We've done quite a few problems on this function. Horizontal line y equals 10 intersects the graph at 2 points, and those points are given by these x coordinates, which are the solutions to our equation. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care. Don't forget to watch the shorts, and bye-bye.